All right, today we are doing section 4.6, medians of a triangle. We are going to find segment lengths in triangles with medians. We will talk about what medians are in just a moment, but first we are going to warm up with a review. There is not a place on your notes for this warm-up. I would recommend jotting it down on another sheet of paper if you need the extra practice. If you felt like you knew what was going on yesterday, then just follow along. All right, we have to classify the triangles as right, acute, or obtuse. In order to do that yesterday, we compared c squared to a squared plus b squared. We did not put a symbol in between them until the end when we knew how to compare them. Now on this problem, I've told you that I don't want decimals for radicals. However, on this problem, if you need to know what the square root of 29 is to compare it to the other two, to see which of the three is the longest, that's fine. So approximately what is the square root of 29? 5.38. So which side has to be C if this one is approximately 5.38? That side. This one is the biggest. We're not going to use the 5.38. We just needed to know which side was the longest. So knowing that that side is the longest, this side's going to be my C. 5 and 3 will be my A and my B. C squared is the square root of 29 quantity squared. A squared is going to be 5 squared plus B squared is 3 squared. What is the square root of 29 squared? 29. Squaring and square rooting are inverse operations. They undo each other. So if we square 29 and then we square root it, or we square root it then we square it, the outcome is just 29. What is 5 squared? Plus 3 squared is, if we add 25 and 9, we get 34. How do 29 and 34 compare? 29 is less than 34, so this triangle is acute. If c squared is smaller, the triangle is acute. On problem 2, which side has to be C? The top one, 12, the longest side. The other two are A and B. So we are going to take 12 squared and compare it to 8 squared plus 6 squared. What is 12 squared? 144. 8 squared. And 6 squared. If I add 64 and 36, that's 100. How do these numbers compare? 144 is greater than 100, making this triangle obtuse. Questions about the first couple of examples? All right, let's do the third one. I think we'll probably skip the last two for today. Seems like those of us who are wanting to participate know what we're doing. Which side has to be C? The 26. A and B are the other two sides. This is a problem we've seen, I feel like, every day that we've done these triangles. We are going to compare 26 squared to 10 squared plus 24 squared. 26 squared is still 676. 110 squared is 124 squared. And if we add 576 and 100, how do these compare? Which makes this a right triangle. Same steps every time, and really it's similar steps to what we were doing previous days. So those problems should be pretty quick. We'll go back to our title slide for a moment. If anyone did not get their objective copied down, now would be the time to do that. All right, today we have a couple definitions and a couple theorems. You can put it on your vocab sheet or you can put it on this note sheet. First vocab word is a median of a triangle. It is a segment from a vertex to the midpoint of the opposite side. We also need to know that the centroid of a triangle is the point where all three medians of the triangle intersect. We will see examples of both of those objects in just a minute. We also have a theorem. The medians of a triangle intersect at a point that is 2/3 of the distance from each vertex to the midpoint of the opposite side. All of that will make a lot more sense once we see it in diagrams. But for now, let's just get the words copied down. All right, here are some examples that you can draw just as diagrams. These are not the 1, 2, 3, 4 examples labeled on your notes. Those will be on the next slide. So these are just what you could put in the diagram or right next to the definition for a median. These are all three medians of the same triangle. They just drew them in three separate diagrams. So what the definition said was that a median goes from a vertex, so from a corner or a point of the triangle, to the midpoint of the opposite side. We know that this is a midpoint because they label those two pieces congruent. So on each of these we go from a vertex or a corner to the midpoint of the other side. So every triangle will have three medians because it has three vertices. We're going to copy down examples on the next slide, but this is an example of what we're about to do on the next slide. We have to draw a median from angle A or vertex A, point A, to its opposite side. Which side length is opposite A? CB. Okay, if we're going to a side, it should have two letters. Side CB is opposite angle A. If I'm splitting 14 at its midpoint, each segment should have a length of, we're splitting 14 in half, 7. So when I draw in my median, we're going to be approximating, but these should be both having a length of 7 and 7. Today we're not going to get out rulers and make sure that it's exact. Okay? We're not given a unit of measurement. But we should know that when we draw in that median, those two segments would each have a length of 7. On all four of these examples, we are going to draw a median from point A to its opposite side. All right, on the first example, we're going to start at point A. Which side length are we going to be splitting in half?
26.
The 26. If we split 26 in half, what do we get? 13. So I have to draw in a median from point A to the opposite side. I do my best to approximate where the midpoint would be, but then to make sure I'm explaining myself, I label that both of those sides must then have, both of those segments on that side should both have a length of 13, showing that I'm splitting it in half. On the second one, somebody new, tell me which side's getting split. On the second example, we start at point A, we go to the opposite side, so we are splitting the side that is marked with a 6. If I split 6 in half, what do I get? 3 and 3. Keatha was saying, can I just use the little congruent marks like that? Yes, you can. That's fine. That's another way of telling me that you know that this median lands at the midpoint. Somebody new, tell me which side's getting split. Keon? 10. This one, it's kind of an easy answer because all the side lengths are 10. But we are going from A to the opposite side. And when we split 10, what do we get? 5 and 5.
So you know you're doing it right at 50.
Good. On example 4, we are splitting the side that is labeled 20. That is the one that's opposite point A. When we split 20, what do we get? 10 and 10. Okay, the question was asked, basically, does the side have to get split evenly or nicely? No, these ones all happen to be divisible by 2. But we can split 19. We would just end up with a decimal. That's fine. We mentioned this a little bit earlier, that the medians intersect at a special point. It's called the centroid. We put that in our vocab. And that the distance from a vertex to that centroid, that special point in this diagram, that would be point P, that distance is 2/3 times the length of that whole median. So for example, at the bottom they put that AP, so from vertex A to the centroid, is equal to 2/3 times the length of the whole median AD. So we take the whole median, we multiply it by 2/3, that gives us the distance from the vertex to the centroid. And it works for all of them, we just have to use a different median every time. So from B to point P, that's going to be 2/3 of B to F. From C to point P, that's 2/3 the length of C to E. This relationship can be a little confusing at times, but hopefully if we practice it, you'll get the hang of it. It won't be so bad. That is the goal. All right, this example is worked out for us from start to finish, just so that we have a guide of what to go off of. So we'll just talk through what it says. It is in your notes so that you can refer back to it. They tell us in the directions that P is the centroid, which means these segments in the middle of the triangle are all medians. They also tell us that the length of KN is 18. They ask us to find both KP and PN, so the two pieces of the median. From that theorem we just talked about, it says that we know that KP from the vertex to the centroid is 2/3 the length of the whole median, KN. So we plug in 18 for KN. 2/3 of 18 is 12. The whole thing from K to N was 18, and this piece of it is 12. So we use our segment addition to figure out the rest of it. No, I don't expect that you're going to set this whole thing back up, but this is where it comes from. We learned this a couple chapters ago at least. The whole thing's 18, part of it's 12. We subtract that off to find the other piece. So PN, that little piece that was left over, would have a length of 6. So then we have successfully found both KP and PN. All right, on number 5, we are asked to find the length of AP, just from a vertex to the centroid. We are told that AD has a length of 60. So to find the length of AP, we are going to take 2/3 times the length of the whole median, which is AD. This is just like the problem above that had all the work written out. What's the length of AD? 60. They told us that in the problem. So we have to take 2/3 times 60. What's 2 times 60?
120.
Divided by 3. What's 12 divided by 3?
4.
So 120 divided by 3 would be 40. Quentin, be quiet. AP has a length of 40, but we're not done. We also need to find the length of PD. If the whole thing has a length of 60 and AP has a length of 40, what does PD have to have a length of? 20. We would take the 60 minus 40 and get that PD equals 20. Next example, similar situation. We are finding HP and PG, given that HG is 36. Which of these two, HP or PG, is the longer piece? PG is the longer piece. So that means that PG is going to be 2/3 the length of the whole thing. What's the whole thing? 36. So in order to calculate that, either get out a calculator or use your skills. We would take 2 times 36 and then divide it by 3. Or you can take 36 divided by 3 and then multiply it by 2. What do we get? 24. PG has a length of 24. So what is HP going to have a length of?
You said 24?
12. Yes, PG would have a length of 24. HP would have a length of 12. We can double check ourselves by adding those back together. We should get 36, do we? Yes, we do. So we know we got those correct. That's how you check it. Those two pieces added together should equal back up to the whole thing. All right, example 7. We are asked to find KP and PM, knowing that KM has a length of 99. Which of those two, KP or PM, is longer? KP is longer. That's the one that starts at the vertex. So we know that KP is going to be 2/3 times the length of KM. What's KM? 99. All right, what's 2/3 of 99? 66. So KP has a length of 66. If KP has a length of 66, what is the length of PM? 33. You can either subtract from 99 or take half of it. But these two numbers should add back up to the whole length of 99. That's how we are sure that this works out. All right, on these ones, we are given different pieces of information. There are going to be multiple ways to approach these problems. You just have to pick the one that's going to work best for you. On example 8, we are asked to find the length of BD, which is a whole entire median, the big long piece of it. We are told that BP has a length of 8. BP is from the vertex to the centroid. So if we apply our theorem, it would say that BP is equal to 2/3 the length of BD. D. Which of those two values do we already know? BP or BD? BP is 8. But then that means we have to get BD by itself. How am I going to get BD by itself? Brandon? Right now, what operation is going on with the 2/3 and the BD? We're multiplying. How do we undo multiplication? Do we divide by fractions? What do we do instead? Multiply by the reciprocal. So we're going to multiply both sides by 3/2. That's going to get rid of those fractions on the right side. We still have to multiply by 3/2 on the other side. So we are taking 8 times 3/2. Did anybody calculate that yet? $12. 8 times 3 is 24, divided by 2 is 12. So BD has a length of 12. Now there's another way of approaching that problem, and some of you might have saw that way of approaching it before. And if that's what you use, that's fine, as long as you showed the right work. Some people might have said that if we know that BP has a length of 8, PD has to have a length of how much? 4. It's half as much. This has a length of 4. Then how would we get the length of the whole thing? Adding them together. So you need to show me 8 plus 4 equals 12, and that's how we got that answer. Whatever you do, you have to show me how you're coming up with your answer. If you don't write anything else down and just put an answer, even if you logically thought through it, I don't know that, you don't get points. So you pick which way you want to do it. I think that the second way of doing it is a little quicker. The first way uses the theorem. So we are told that from the vertex to the centroid has a length of 2. We are asked to find the whole entire median. If EP has a length of 2, what's the length of PH?
1.
So I can say that I know PH has to have a length of 1. It's half as long as the other piece. And how could I find the length of EH?
Plus 1.
We would have to add the two pieces together. So EH has a length of 3. If you were to go about it the theorem way, that would be fine. You would just have that 2 equals 2/3 times EH, multiply both sides by 3/2, and you would end up with the same answer of 3. All right, on the last one. We are asked to find the length of KM. We know that KP from the vertex to the centroid has a length of 24. If that's the case, what's the length of PM?
12.
PM is, in case some of you aren't sure how we're getting this, we're taking that piece and dividing it by 2. That would have a length of 12. How would I come up with the whole thing? Add the two pieces together. 24 plus 12 gives me 36. These problems should not be terribly hard, but you have to keep the relationships separate, and you have to know if you're starting from the vertex or if you're at a midpoint where the centroid is. You've got to keep it all straight. Also, don't forget when you do all this that this is not the only thing we know about medians. How would I compare the lengths on this example of JM to ML? What do I know about those? They have to be congruent. Students get too caught up in the whole centroid thing that they forget that those medians are still dividing those sides in half. Do we have questions?